Imagine a puzzle so perplexing it stumped the greatest minds of the ancient world, not just for a day or a year but for centuries. This wasn't a simple word game or a logical twist, it was a geometric riddle whispered from the lips of an oracle and delivered as a divine command. The challenge seemed straightforward, almost deceptively so, yet it held a secret that would elude the likes of Plato and Archimedes. Born from a story of plague and divine appeasement, it became a mathematical obsession. It haunted the academies of Athens, a testament that even genius has limits when facing the truly unknown. The riddle is known today as the Delian problem, or more simply, doubling the cube. Picture a cube, a perfect block of marble. Now build another with exactly twice the volume. The story begins not in a quiet study, but in a city gripped by fear. According to legend, in 430 BC, a terrible plague swept through Athens, claiming thousands, including its great leader Pericles. Desperate, they sailed to Delos to consult Apollo's oracle. They begged for an end to the pestilence. The response was cryptic and unexpected, not about morals nor forgotten sacrifice. The offense was geometric. The cubical altar was too small. Build a new altar, said the oracle, exactly double the volume and still perfectly cubical. The command was clear, the method was not. Athens rushed to obey. First, they doubled the edge length, but that made it 8 times bigger, surely angering the gods further. The plague raged on. They turned to the mathematicians. The riddle reached Plato's academy, stripped of urgency, reborn as pure challenge. No longer just saving Athens, but probing numbers and space. Could the hallowed tools, compass and straight edge, construct the precise new edge? Thus, the name, the Delian problem. The legend gives the puzzle its weight, a matter of life, death, and logical precision. Whether true in detail is beside the point, it framed a mystery worthy of genius. The altar became a symbol of a hidden truth, a number beyond mortal construction. The quest was on to understand the fabric of the cosmos. The Greeks, armed with compass and straight edge, were masters of certain numbers. With these tools, they did wonders. Add, subtract, multiply, and divide. Even extract square roots because lines and circles make those operations possible. Given a length x, you get area x squared and take square roots back, but doubling a cube needs a volume of 2, so x3 would number 2, the cube root of 2. Approximately 1.2599, never repeating. For 2 millennia, the problem marked geometry's limits. A final verdict arrived in the 19th century, in 1837, by Pierre Wansel, laying the ancient ghost to rest. Using the new language of abstract algebra, a realm the Greeks never imagined, he proved 2 cannot be constructed by their rules. Not hard, impossible. A landmark shift in mathematics, prove when no solution can exist under constraints. From finding answers to understanding structure, the rules of the game set what is possible. Their failure was not intellect, but the elegance and limits of their system. Their tools could not bridge to the world of cubic numbers. Its legacy? Think beyond the toolkit, outside the box, outside the circle, and outside the line. Menaechmus's cheat, conic sections, wasn't a dead end. It sparked the study of richer curves crucial to modern science and engineering. From orbits of planets to satellite dishes and telescope lenses, frustration became innovation. The Delian problem teaches how discovery works. Limits can catalyze breakthroughs. Their failure revealed a deeper structure of mathematics. Sometimes the most important questions force us to invent new ways of thinking. The ghost of the impossible cube still haunts us, not as failure, but as an enduring call to question assumptions and push beyond accepted rules.